Um, Hello, everyone. Can you see us? Just give me an acknowledgement on the chat, if possible. Yes, perfect, perfect. Thank you, Amit, Gaurav, Nikhil. So thank you all for joining for the webinar on urban mobility, location APIs, and use case discussions from Here Technologies. So before we get into the webinar and introducing the speakers, I would like to give a brief about the overall program that we are doing. That is the NIPP Mobility Challenge. So this is the second edition of the challenge, and the idea here is to create a platform where we are bringing the corporates and startups together to solve the problems on flow of like transportation, logistics, sharing information, and also this is a good opportunity for us to get much more engaged with the enterprises who have posted these use cases, and understand in depth on what their focus areas are, what their priorities are, and what their expectations are from the startups who are looking to solve these challenges. So before we begin, I just want to give some pointers to all the audience. So any questions that any of the attendees might have for the speakers, I would request you to hold it till the end of the webinar. So in the last 10-15 minutes, we can take to discuss your questions and raise your questions to the speakers, and we will only be taking the questions through the chat in which you have acknowledged just now. So please keep posting your questions over there, and once the session is over, we'll take proper time to go through them and take up the answers and discussions with the speakers. Anyways, without any delay, we have Binesh and Girish from Here Technologies, and in an overview, what they want to talk about is what Here Technology is doing, what their primary focus areas are. Girish will be discussing a little more on the location APIs and urban mobility, and we will also take some good time to show some light on the use cases which Here Technologies has posted as a part of the NIPP Mobility Challenge, and discuss a little further on each and every use case. So Girish, Binesh, I think you can hear me. So I think we are good to go. You can get started, and I'll just my screen while you are talking. Yeah.
Sure. Thank you, Rohit. I believe I'm audible, right?
Yes, yes, Binesh, you're audible.
Great. Let me just share the presentation. 1 second.
Yeah.
Is it visible? I'm not able to see my deck actually here.
Uh, I mean, yeah, your screen is visible.
Yep.
Yes. Oh,
Is it visible now?
yes, yes, it's visible now. Yeah.
Wow. Wow. Great. Great. Okay. And first of all, hello, everyone. A very good afternoon. And I hope you all are doing good. So unfortunately, we were not able to meet up physically, but based on the current condition, this was the best approach which NASCOM team was able to execute, and we truly appreciate the workaround for it. But before we move ahead with the slides, we also really appreciate the people in the call to take their valuable time for this session. So we have around 1 hour to touch base all these topics or agenda points. But today we have Girish and myself, Binesh. We will just give an overview on these points, and I will be talking about the here technologies, the intro part, and the urban mobility, and followed by the use cases and location APIs, by Girish. And since Rohit has already said the context, that it will be a humble request that if anybody want to note down any of the points or queries, which we can discuss during the Q&A. Right now, let me first begin briefly introducing here technologies. So we are basically a location data and technology platform. So on behalf of our customers, we usually seek to understand and model a world that's always moving and changing. So directly or indirectly, we produce a digital representation of reality. So obviously, we are working with maps, and it's much more than a map. When we talk about more than maps, it's like living, which is like a dynamic or continuously updating, right? It just don't cover only roads, right? More and more of the world in kind of a 2D and a 3D environment. So few cases like if you see the next few slides, you will try to understand that a lot of like buildings, factories, campuses or airports, which we are able to formulate into from a 2D to a 3D model also. But increasingly it also incorporates the stuff that moves, what Rohit was also mentioning. That's one of the theme of the NIPP mobility, right? Like moving of vehicles, goods, IoT sensors, people. So our representation of reality is the basis for us, and usually for our customers, to understand how people, places, and things connect together.
Binesh, did you log off by chance?
Hey, Rohit, I think he has lost the connection. Let me just...
Yeah. So yeah, guys. So meanwhile, I'll just share the link of the mobility challenge on the chat, where you can just take some time to also go through the landing page, and you can actually go through the use cases which are already there, and you can apply then and there over there. For any queries, you will also find the contact IDs you can reach out to, and any of the use cases which are hosted on here technologies, or sorry, hosted by here technologies, we discuss it today with Girish and Binesh post this webinar.
Hey, Rohit, I can actually share and talk on this unless he comes back. I'm not able to reach him as well.
Sure. No worries. You do it. I'll try and reach him on the chat. Yeah.
Yeah, sure.
Yeah.
Can you just confirm if you can see my screen?
Yes, we can see the scene.
Okay, fine. So continuing on what Binesh was talking about, here Technologies provides location content primarily in different forms, like 2D maps, 3D maps, or buildings, the city city models, the maps for autonomous driving, those kind of use cases. That is that is the data part of the here technologies, and then we also provide services on top of that data, which is primarily location-based services. The company collects around, thousands of terabytes of location data from a number of sources every year. We have our own cars, which is primarily built in order to collect a LiDAR and images driving across different parts of the world, and that's how we primarily create most of our map data. There are many other sources as well that we either buy from other people or sensor database sources, IoT based sources. Those kind of things also comes into play. Also, it's all that's one part of it's collecting the data, but it also needs to be processed in order to actually build the map, which you can actually use in phones or cars or any of these or as services. Through the location service APIs. So that's by using artificial intelligence and machine learning in many of these steps in order to process these input data and convert that into maps and keep updating the maps. That's very critical. Things keep changing, and then we need to actually reflect those in the maps. We build location tools, APIs, SDKs, and applications that leverage this data and create more data. That's what we're actually going to actually walk through today. The APIs that you can actually use in order to build applications using the data that we already have, and that helps us to also have more data and you guys to solve problems in various kind of problems related to mobility, all of which you can exploit to run your own product services and solutions. You can also easily and securely exchange location data with others and monetize your data. Monetize your data should you choose to. So this is the platform side of things. So there's data, there is services, and there is a platform. So platform is where you can bring your own data, which you can overlay on top of the here map data, and then you can build your own services on top of that. So you actually get like multiple layers of data, and the more number of layers data that you have, you actually can get more. You can actually get more context about certain location. Those kind of aspects also come into. We'll go through some of those details in the technical part of things. Location platform in numbers 48 serving use cases across multiple industries, 260K direct developers currently in platform, around 3 million indirect developers, 80 billion API calls. These are some of the numbers. I'm quickly going through this. Industry and market challenges we address. Location technology opens up new opportunities in multiple industries and markets. This is you don't have to explain this, right? You take any use cases, almost all of them have location as one of the primary data in that that you would need in order to get more context. Some of these are like automotive industry, primarily all the cars that now has navigation inbuilt into the cars. Transport and logistics industries, which normally need a lot of tracking of the assets or the logistics when you transport things across. What's the status of those, where it's reached, and what's the ETAs around it. Tech, media, telecom, retail industries, public sector, finance and insurance, manufacturing, accommodation and food and services, healthcare. These are some of the markets. Supply chain, fleet management, urban mobility, connected driving, infrastructure planning. Again, many of these things you would actually connect when we talk about the APIs involved behind all these things. So mostly to give an idea about what are the markets that we normally work on. Location is key to addressing major industry challenges in several markets. Automotive. So within automotive, you have automotive have been like one of our primary area for years, while we are actually now getting into other markets as well. Automotive has connected driving, urban mobility, supply chain, these aspects. So connected driving itself includes a lot of what you call the autonomous driving related use cases and different ways of getting you information about what's happening around the when you actually take a particular route. If there are accidents happen and traffic related aspects, everything that's all part of connected driving. Okay, I'm going to skip a few of these things so we can save some time for the APIs. So to give an idea about like the history of the company itself, it was founded in 1985. It was one of the first location, a company that started working on collecting or building map data so that it can be used for driving purposes, in-car navigation purposes. Right now, around 9,000 people across different parts, across 5 continents, 56 countries. We have major offices, engineering offices, and in offices where we actually have people working on building these maps with various tools using the input sources. And we also have a lot of local offices where we actually coordinate our collection of these inputs, especially driving our own cars in many places, how to schedule those things, etc. We have invested in location technology across almost 4 decades. Should just so this bit of history, NAVTech is what the company was called at that point. In 1990s, we deployed the first in-car satellite navigation. And in 2004, our technologies used in the first advanced driver assistance systems. Advanced driver assistance systems helps you to warn against, for example, sharp curves that's coming on your way. So how do you warn you to reduce the speeds, adjust different kind of the altitude differences. How do you optimize your vehicle accelerations for those kind of ups and downs that coming on your roads? And it's also used for creating a map for mobile devices. So one of the earliest maps in Nokia phones was actually created using here maps. And later in 2008, NAVTech was bought by Nokia. And in 2011, NAVTech forms core of Nokia's broader location business, which was called Nokia's Location and Commerce business. In 2012, we became Nokia branded it as here, which was still a Nokia company. In 2015, Nokia sold this into BMW, Audi, and Daimler. So they acquired it as a consortium, forming a consortium to develop high-definition mapping for self-driving vehicles and other applications that these companies were working, are currently still working. 2016, we started to share our database of location data on an open platform. And 2017, 2018, here shareholder structure broadens with Intel, Bosch, Pioneer, and Continental as new investors. And 2020 here welcomes Mitsubishi Corporation and NTT as new investors, both of these Japanese firms. That's an overview. It's kind of repeat of that, so I'm going to skip that. Rohit, I'm not sure if you actually got connected to. Okay, let's see.
No, I haven't connected to Binesh yet. Maybe you can start with the location API part of it.
Okay. Yeah, so I can actually start with, I can even quickly go through if there's anything more, to be talked in this. I think it's a few more slides, so let me continue. This is some of the customer who we are work with. Give a list of those customers here. Yeah, so this is something that I wanted Binesh to talk on. I'll skip this. If he comes back, he will talk more on this. Okay, so I can jump into the use cases that we were working with NASCOM on, startups. One is actually the city bus tracking, customized and delightful user experience for public transport in cities. And second is outdoor workforce tracking, improve the business operations through data and technology to grow to grow business and deliver profit. To get into a bit more detail into this, so the city bus tracking is, how the how the bus how do you travel using using city buses. It's not always as easy as like you get into a bus and travel. So buses have, the drawback is that the commuters have to wait for some time. You probably don't know when is the next bus coming, and that leads into you actually losing some time and not really being efficient in traveling. So that's where most of the time we actually prefer something which is immediately available, which we can travel. We actually use taxis or one of those cab hailing services or any of those things. So the idea is actually, the current challenges is like the flexibility that is actually a key requirement. Most transport bodies don't have their data that need for real-time bus tracking, right? So they don't know where the buses are, so they cannot really track the buses, first of all, at least in many cases. I'm sure there are places where it's available, but many places it is not. People need to be able to use buses for multiple trips in succession. Rigid timetables and set routes can make buses less appealing and less effective. All of you must have experienced the same thing. When if you travel by bus, you have one bus and then you have to get down somewhere and then catch another bus, and then again you will probably have to wait, or you don't know when the next bus is. Those kind of things are the challenge, are again challenges in it. Convenience is also vitally important. Having to wait for a long time, especially if if it is in scorching sun or rain or chilly weather. So those are not going to help you if you want to wait for the bus. Reliability is an important requirement for people to use buses. Transit systems must be designed so the buses run on time, and many bus rapid systems around the world deliver fast and reliable services. So yeah, sometimes a bus is no more, it's broken down and it's not really coming. You're waiting for it. You don't know about it, and you further have to wait more time. So this use case is to actually address some of these problems. So business requirements are a system needs to be created which uses combination of hardware devices and here location services for tracking of city buses. Development of a reference application or a system which includes services of here location APIs or here platform. Solutions suggested must have a fleet associated. Must have fleet associated from transit authorities as an end-to-end solution proposal. So this is primarily an end-to-end solution for this problem, where you can actually as a commuter, you can actually go and you want to go from A to B, and then you can go and check the bus availabilities and what's the next bus coming, where it has reached, and how far it's for your nearest stop, and how do you know if the bus is full, or what's the do you actually get seats, or even if it is really crowded. And then also the connectivity. Once you get into the bus, what's the next bus which you have to connect to, what time it's coming, the details around that. Also, you could think of things like how do you seamlessly use the system of payments, so you don't have to really pay by cash, or so those aspects could be considered. And the connectivity, as I said, when is the next bus coming, and how long you have to wait. primarily, even if you would want to even track buses, right? I mean, okay, you have like you have two buses coming probably back to back, and the back to back in the sense there might be gaps, but then you can actually plan something for that gap, so you can skip one bus and catch the next bus, but you know when the next bus is coming, so you can actually plan things accordingly. So it's kind of looking for an end-to-end solution for this, using implementation of that, using here location APIs and platform. The second use case is it's actually to track the outdoor workforce, improve the business operations through data and technology to grow business and deliver profit. This is more of an optimization use case for workforces. The ETA in real time. For example, if a customer calls the main office asking when to expect you, exact ETA will give the information required. For example, like you're expecting a parcel to be arriving your home, and you want to actually know what time it would be coming, where that person has reached, and so that you can plan your when you want to go out, or how long you have to wait at home to actually receive it. Those aspects. Another part of that is that the person who is actually delivering it should also be efficiently delivering it, making use of the shortest or the fastest routes, connecting all the delivery points on that route, so he actually can minimize going back and forth between places on the same routes. Viewing the locations of your scheduled jobs. So yeah, that's the second part, the create more efficient schedules. Improve the productivity. Management can check their outdoor workforce via GPS tracking instead of texting or calling. Management can trace their workforce by just looking up their location. So that's the current challenge is being able to locate employees quickly and efficiently for both their safety as well as ability to deploy them with the speed to another location. Ensure the company's property is being used in the correct way. You can also this can also be used to not really track for example, the hardware or not only just the people, the workforce as employees, but also workforce in terms of machines, or like for example, earth movers or any of those kind of machines that needs to be tracked, where it is, and what are the points they need to work on in a particular day. How do you plan all those, optimize all those? Increasing and improving performance with time tracking, helping employees to boost their own productivity, keeping track of their performance and working hours, resources, and equipment in order to improve productivity. Business requirements is an end-to-end system, needs to be created with which uses combination of location services for tracking outdoor hardware devices and workforce, workforce employees, or or hardware development for a reference application of or a system which includes services of here tracking platform and targeted Android devices. You can post more questions on these things, in the chat, and we will try to answer those. But the next step we're getting into is the actual location APIs. I probably have half an hour to talk on that, 20 minutes to talk on that. Okay. To get started on that, so this is more like I'm actually sharing the developer.here.com. That's normally where you would start when you want to solve these problems, and once you have certain understanding of the problem, the next step would be you actually go and understand what kind of APIs and what kind of hardware software options are available for you in order to solve some of these cases. So I'm going to primarily walk through the developerhere.com portal with the documentation part of it. So you actually see that there are location services, section in the documentation, which primarily talks about maps, geocoding and search, routing, free telematics, geovisualization, live sense SDK, and geo enrichment. We'll get into more details of it, but these are primarily the map-related, the location services, which is primarily three types in that: a JavaScript based way of creating maps, which is primarily if you're building anything on a web browser, you would actually use the JavaScript APIs and components that we provide. The second one is REST API. So that is if you are working with, if you don't want to work with JavaScript in a browser, but if you are building your own UI and you want to access the map data or make requests to, find routes or whatever you do with maps, you can actually use the REST APIs to get the same thing, functionalities. And another use is definitely in the backend systems, right? So you're writing something in Java or any other, other programming language which is in the backend, and then the backend systems need to process certain some types of data that you have in order, along with location data. In that case, you want to access the location data from the backend, then that's where you would make use of the REST APIs. And then you have the two other, the SDKs for mobile applications. So that includes an iOS SDK and an Android SDK. So that gives you an SDK where you can actually start building your Android applications on top of that SDK. So most of the core functionalities of that's provided, that's listed here, would be actually available in your SDK as APIs in the corresponding languages in those two platforms. There are a few other things that you will see here. Tracking and positioning. This is tracking and positioning is sorry about that. Tracking and positioning is so this is more like tracking the hardware IoT devices, and I didn't mean to do that. Yeah, so tracking is more, tracking devices, IoT devices. You can use phones in order to track things, but if you have cases where you cannot really trust tracking using phones, but for example, a hardware which you want to tag with a tracking tag, then you would want to actually put that on that hardware, like a what do you call it, a earth mover or any of those. An IoT device is another example, right? Any kind of IoT device that actually knows about location and you want to report that locations, back or track that device, then that's where you have tracking and positioning APIs. Now, this is more like there are multiple parts into it, like there are positioning APIs and tracking APIs. And then you have the client code, which you can run in an IoT device, like a C or C++ based code that you can actually run it. And there are GitHub links where you can actually download that code and try to use that code in order to track the devices. So the tracking, I'm probably getting into the details of it, but we'll actually get into details once we go into that page. Another part of this is map making. This is called Here Studio. So one of the things normally you would come across when you solve when you solve location-related problem is that, okay, you get map, you get the road networks, you get the, if you want the buildings and the places and all those things you get from Here Maps. But what about like locations that may be very custom, like you're tracking, for example, you want to track like all the construction sites in a city. So the places where the construction sites are, but it's not available in a map because we don't really track track all the construction sites, or we don't have that in our maps. But then that those construction site locations. So you can actually build your own data on top of the Here map. And you can actually use that, use the Here Studio. So Here Studio provides a UI where you can go and draw your own data. You can actually draw polylines or polygons or points, and then actually tag it with the different attributes. And then you can actually use the APIs of the studio, the REST APIs of the studio, to access that. For example, if you have a JavaScript application, and then you use Here map display, and then you can call the studio APIs to get your own data and an overlay on top of it, and then you can find routes between those those locations, or the fastest routes between those plan accordingly. Those kind of things is, so it's a quick way for you to actually create your own custom content and use that in other APIs and APIs. Here platform is more for build, exchange, and create. This is more enterprise use cases, especially if you're working with like companies that work with IoT devices or sensors. For example, the car companies actually send us a lot of these car sensor data. For example, like cars detect signs and road geometries and everything. Some of the advanced cars today does those things already, and they actually stream those data into the system. So this is more like high volume data processing, either stream data or processing batch data. An example would be like you get all these points, all these locations from different mobile devices or cars, which actually can be used in order to derive the traffic on a road. Right, that's how you actually get the traffic in map APIs, because we know, the phones or the cars keep reporting the speed of that, the position of, or the actual GPS positions of that. From that, we know the speed of it, and then you know if the average speed is less than certain thing, it's a red. It's otherwise it's a yellow or a green. So in order to do those kind of real time processing, that's what here platform is about. Then automotive use cases are primarily very custom to automotive companies, like in-vehicle infotainment. So we have systems which actually can be plugged into the car in order to enable navigation, plus the navigation along with additional other infotainment aspects like musics and videos and the car environment, everything. Connected vehicle service, I mentioned about like speed limit warnings, accident hazards, those kind of more dynamic events that's happening around the route that you're taking. Highly autonomous driving, surely the level 3 and above autonomy, which involves limited to fully automated driving. Limited in the sense you can drive the car drives automatically in a highway, but when you get out of the highway, the car asks you to take control of it. That's like a level 3, and then level 4 is more, you can do that in most of the time. Level 5 is like fully autonomous. You don't have anything in the car as a control, like steering wheel. Still not really, still a dream probably. It may be possible in control environments, everything, but not more than that. Over-the-air software updates are primarily for autonomous cars and connected vehicle services. How do you update the maps over the air into the cars or any other devices that need maps? That's a general overview of what we offer as a platform, and we'll actually dig a bit deeper into the documentation. Okay, so going back into the location services, the first one we talked about, what you get in this is like if you're the developer, you will actually immediately see that, okay, you have a JavaScript interface, you have mobile SDKs, there's a light and premium version. Light edition comes with the freemium package, and premium edition have more, the pricing models will be available. It's also available in another tab here. But then this is the JavaScript way of, I'll just quickly, I may have like 15 more minutes. Okay, so I'll try to cover a bit more details. It's clear. I'll try to avoid scrolling too much. Yeah, so this is primarily getting into the code and some examples of how do you include include the map, the JavaScript, into your JavaScript, into your code, and how do you make it work? So if you want to actually create a new map, display on your web page, how do you do that? That's pretty much here. You have a documentation on how do you get the API keys and all that. There's a different section for that. Not going into that. It has pretty bit detail about like how do you initialize the map, code examples, how does it look when it is initialized, complete HTML page. Yeah, so my intention is to just give you a glimpse of what's there in the documentation. Getting started. Okay. So this is interactive maps. So this is primarily if you want to show a map, and interact with that map. That's what you're actually getting at. Vector tiles are tiles to access freshest here map data and customize the map style to fit your needs. You can go through the detail of it. I'm not going through each of them. Map image, this gets you image and pre-rendered images. For example, if you don't want to use the interactive maps, but you want to just have a snapshot of a map of some area which you wanted to share with somebody, or those kind of aspects, you can actually use this as a REST API. I'll probably go to a little bit into this documentation because this is more. So the first one I showed is JavaScript. This is the Android SDK part of it, which will help you to understand how do you draw, so once you have the SDK and you initialize the SDK, how do you actually add more data or draw some your own data onto that. For example, if you actually using here Studio to create your own polylines to represent certain custom data, and then how do you actually get that into your SDK and then render that in the SDK as polylines or polygons and labels on top of it. So those kind of things are kind of detailed here. You can see how a polyline is used, drawn in on top of it. Yeah, code examples. A circle. Adding some images into the map. This is more how do you select a marker? So if you put certain markers, and when you click on those markers, how do you pick the events around that? Adding any kind of metadata. Yeah, again, I'm not really going. It's a pretty detailed documentation you should be able to go through, but that's a glimpse of that. Let me see if I can get into how do you set up the Android SDK. Featureless minimum requirements. Just start. Okay, try example applications. So you have the GitHub, for here GitHub, and you have all the applications. All the sample code that you see here is available in GitHub. And here you can actually see how do you use the example directly. So if you actually go to GitHub and download the examples, you should, and if you have the development environment set up for Android then you should be able to load and run the application and get the SD, your application running on the Android emulator. Creating an Android project. There are a few things that you need to take care once you take that code. Integrate the here SDK into the Android application that you created. Set your credentials. Where do you set the credentials? Those details handle the permissions in Android, especially the location, the GPS access, everything. Add the map view. How do you create the view of that? The map view into the application. Load the map on scene. Again, shortcutting here. You can see this is a view that you get. And then this is the view with a satellite imagery as the background. Few areas of troubleshooting. What else in it? Create custom map styles. You can go to the left side panel. That will give you how to create and load custom map styles, custom raster layers, rotate the map, tilt the map, change map location, listen to camera changes, animate the location, control map actions, attach gesture listeners, and drawing different things, search for places. That should allow you to bring the search option, and you type and it should actually give you the locations, and then it zooms into the location that you want to start. Getting search. Okay, traffic. How do you get traffic data? How do you get directions, right? Get the routes, the APIs in order to, let's quickly check that. Yeah, so you can see some of the examples here, like in order to do anything with related to routes, you actually start the routing engine, and then you work with the routing engine with the positions, start point and end point. You can add multiple waypoints into the route. So if you want to go from one A to B, and you can, I mean, there are more examples down here. Yeah, there's actually A to B, and then you can actually see that, okay, you want to go to from starting point to destination via waypoint 1, waypoint 2, then you can actually get the route which involves those. There are more options available in it. Like you can actually get things like things which is not only just waypoint, but things which goes closer to certain location. Yeah, match location, and yeah, near to this restaurant, so it goes near to the restaurant, if not through the restaurant. A lot of those options. So this is more of giving you an idea about like what is there in the SDK, Android and iOS SDK. So all these are there in both SDKs. Let me cover a few more things before we end with this. So I talked about Here Studio. So this is a documentation about Here Studio, where I told like you can go. Here Studio gives you a few things, like there is a Here API. I mean, a Here Studio API, Here CLI, the command line interface, and there is the Studio. It was called XYZ, and we are still actually updating the naming into the Here Studio, then XYZ. It was initially called XYZ. Again, you can see how to make that work. The whole how do you actually install command line? How do you create your account and get access to it? And then how do you use REST APIs in order to publish your data? How do you create the Here Studio web UI in order to create data? Those aspects. So basically, it's this way. You can actually go to Here Studio in user interface, create your space and layers there, and then you can select a layer, put your data in the map wherever you want to, whichever location you want to create data, zoom into that. You can draw things, you can add attributes into that, and once you have published that data, then you have the APIs, which is the Here XYZ Hub API, which is called here. It's actually now called Here Studio APIs. That would actually allow you to access the same data anywhere. So you can actually create all this data, and then you can actually access it either in an Android phone, in the Android SDK, or in a backend system, or in a JavaScript application. Going back to some of these APIs, map feedback, map time. Geocoding and search is primarily like the APIs in order to do the say, for example, a latitude, longitude, and you want to know what is that place, or the other way around. If you know the place, what's the actual location of that? It's normally when you search for a place, you get a place name, and then you get the latitude, longitude for that, and that's what you use when you give it to the routing API. You would have to either. I mean, you have multiple options. You can use either latitude, longitude as an input, or you can use a place or an address for that as well. And this is the routing part I talked about just now. The transit is another one, which is primarily like something which is very useful for some of the use cases we talked about. So transit is APIs that allows you to actually get from one point to the other, considering all kind of transport options. Okay, you take the train first, go to from A to B, take the bus from B to C, and then take the ferry from C to D, and that's how you reach from A to D. So it gives you the complete complete route with different transportation options. Okay, traffic APIs gives you the traffic information on your route. So if you actually give the route, it should give you the traffic data, and it actually gives you in different forms. Like it gives you as like a JSON output where it tells you which roads have what traffic, or it gives you like images of traffic, the red green kind of images, which is actually pre-rendered into a image, into a base map image. Large-scale metrics routing calculates the best routes through one or more locations, showing distance and ETAs from up to 10,000 origins and destinations. Can get into the details of that. I'm not super familiar with that API. Location service, fleet telematics is something, again, very useful for when you work with these, both of these use cases, actually. Get access to advanced location algorithms for fleet management use cases like geofencing, route matching, toll cost, and more. Custom locations, not really going to go there. Let's look at this a bit. Again, you have the same, you have the use cases detailed here. Maps and layers find real time. I'm trying to see a use case which can be correlated to the use cases we have. Custom routes, waypoint storing, tracking with EP update. Yeah, so not going deep into this, but you can actually look at some of these pictures, and the fleet telemetry continuously computes routes while the vehicle is in travel to update the ETA after the initial route planning. Call the routing again every few minutes. Positions, electric vehicle. APIs to match GPS traces. These are primarily useful if you wanted, like, a car traveled from A to B in certain route, and at the end of the route you want to calculate the price of what's the actual price, I mean the actual amount that user has to pay. So you actually take those GPS points and then use match that into the route in order to get the actual route that user actually traveled, and that helps you to calculate the cost of that. Credentials examples. Route calculations. For example, like one of this is like route with toll cost, right? So if you take a particular route, you might have tolls involved in that, and it'll actually tell you how much it costs you to take to go through that route. Find best way sequence. Pick up additional items along the route. Again, fleet management and delivery and pickup kind of, so you can actually use these examples. I mean, these are actually shown in a page where you can actually try out these things. I'm going into those details. So now pick up additional items. Calculate ISO line along the route. So ISO line routing is like, it's very useful when you want to, if you want to know, like, okay, within next half an hour, what are the areas you can reach from where you are currently, right? So depending on the traffic. So it gives you like a polygonal boundary where you will be able to reach within a certain time that you gave. Match GPS. Okay, there are many examples in this. My primary goal here would be to just show you some of these things. So you can go and find out more details and have questions later. Traffic.
Yeah, Girish, so can we take like 5 minutes to take some questions from the attendees?
Yeah, sure. Can I have like a minute?
Yeah, please.
25. Okay. So those, I haven't really covered everything that I wanted to cover. There are many, and it was obvious that we may not be able to cover the whole thing. Or I just show the, one more part. There is a tutorial section, and if you go here, you can actually see it. The documentation that I showed so far was in this one. The resources part has tutorials and developer blogs. So that also has a lot of examples. You can actually see like how do you switch from some of our competitors into our, the here map. For the here, there are React related examples, JavaScript examples in the map, application with map API. JavaScript API. HardGL is something that if you want to like have 3D rendering with high with high volume 3D rendering in a web-based application. HARP is a 3D rendering library that we develop. It's an open source library from here. You can see location aware Alexa skill. So it's also, the platform is also available in different cloud platforms like AWS and Azure and MuleSoft. You can take a look at those things. If you're developing something on the cloud platforms and you want to use APIs directly in the cloud, that's possible. A lot of those here. So that's it's a page with a lot of examples and a lot of use cases covered in this. And another one is the developer blogs. So I'll close with that. Just a glimpse of it. Something more contextual for now. Okay, so that's pretty much it. I'm closing with that. Rohit, you can take over.
Yes. So I think we have one question on the chat from Nikhil. So the question is more on, they want to Nikhil wants to understand if there is any use case for the utility sector, and if there is any support for Street View or AR technologies that here technology is using.
Okay. So AR related, there is, so depending on it's a question which has probably so much context behind it. So I'm not sure if I can directly answer that here, but in the page that I showed in the developer blogs, you should actually see something about AR in that. I'm trying to just search for that. Let me note down that question. Can we actually get back on that later, offline? Rohit, that's fine.
Yes, Girish. Sure, Nikhil. Nikhil, you can write to this email ID. And then I'll connect you to Girish. To connect offline.
Okay.
Perfect. Any other questions, guys? I think Binesh has also joined.
Yeah. I just had one point here. I think someone had actually written about the asynchronous real-time digital, right? And they were actually asking about the integration of API, right?
Yeah.
Okay, so if you want to get it connected through our APIs to some patients, probably we can also look into it. So as of now, we have the certain APIs which talks about the live location of any kind of member, but with patients, we need to actually deep dive. So that is one of the area which we can look into it.
Sure.
Yeah. Right. I mean, if it is I'm just reading that again, synchronous real time in digital healthcare system. That's scary. But yeah, I think Jayakar Johnson has sent it. So I'll get in touch, or we can actually get in touch with him. He has shared his details.
Right.
Okay. Yeah. So I think if it's related to tracking, we have I talked about a bit on that the IoT devices tracking those devices. So there is a GitHub where you have C or C++ code that you can actually use in the hardware devices. I don't really know the exact details of it. We'll have to figure that out, but we can actually share you the details of it as
well. Perfect. So I think that is pretty much it. I mean, for all the attendees, who are live right now, they can reach out to Binesh, or you can just reach out to the mail ID which I mentioned earlier.
Right.
That you might have where you want to get connected to here technologies team. Just going back to our program that we are doing, the NIPP Mobility Challenge. So, I'm again just posting the link here. You can just go to it. All the use cases from here technologies as well as other companies are posted there, quite in detail. Identify the use cases which would be a little relevant for you. Gaurav, what is the timeline for Mobility Challenge? So the applications are currently open. So all the startups or student teams or developers can apply on the link which I just mentioned. The applications will be open till March 31st. It would be ideal for everyone to just have a look at the page and then go through the use cases which are like very simplified for everyone's understanding. Okay, I believe there are no more questions from our audience. So thank you so much, Girish and Binesh, for your time. We'll be exploring more forums where we can have discussions with here technologies in a little more detail. In coming time post this challenge and take some of the discussions forward. I'll connect the attendees who have questions, further questions to the points that we discussed today to Girish, Binesh, both of you separately. So,
Sure.
we can take those discussions offline.
Sure. Thank you for everything.
Thank you, Girish.
Thank you. Yeah. Thanks,
Binesh.
everyone.
Thank
Thank
you,
you,
everyone.
everyone. Yeah.
Bye-bye.
Bye-bye.
Okay, bye. Have a nice weekend, guys.
Yeah. Bye-bye.